All right, so for the second part of this section, we're going to talk about probabilities involving or. We might say the probability of this or that. And so, we might say, call this the probability of this or that. Now, the book won't do that, but if I refer to it, I might say that. So before we start working these, we actually have to talk about the two situations that are going to evolve. Okay? So before we can work these, we have to talk about the two scenarios that can happen. Okay, so the two scenarios when dealing with this or that is the following. The events are mutually exclusive. Okay? That's one of the cases. Now, this means mutually exclusive, that's like a definition. This means the two events cannot happen at the same time. The book says it is impossible for these two events to happen at the same time. An example of a situation where it's impossible for two events to happen at the same time are the following. Find the probability of drawing one card from a deck of 52, from a standard deck of 52, and that card is either a club or a red card, or a red card. Okay. Now, to remind ourselves, a club is black, and then the only red cards are hearts and diamonds. Since a club is not red, then it is impossible to choose a card from a deck of 52 in which the card is both red and the club. Okay. Since that can't happen, we call that mutually exclusive. Now, the other scenario is if the two events are not mutually exclusive. Okay, if the events are not mutually exclusive, that means that they could happen at the same time. This means the two events could occur at the same time. If they are not mutually exclusive. I know that grammar is not perfect, but I wanted to kind of emphasize that that's what we're talking about in the second one. So if I think back to a deck of cards, find the probability of drawing one card from the standard deck of 52 and that card is either a club or a king. Okay, so this could happen at the same time. So here's a club, here's another club. Okay, so there's a bunch of clubs in this deck, but notice there is a situation where one of my clubs is a king. So we say that this situation, these two situations are not mutually exclusive. Okay. So when we encounter these types of problems, we have to first say, is it mutually exclusive or not? And then if it's mutually exclusive, we treat it one way. If it's not mutually exclusive, we treat it another way. Okay. All right, so I'm going to go to a new sheet of paper. If events A and B are mutually exclusive, we have a formula for that. Okay. Then the probability of A or B is equal to the probability of A plus the probability of B. So going back to the example we talked about before. I asked, well, I gave you an example of a situation. But my question is, what is the probability of choosing one card from a deck of 52 and that card is a red card or a club? Is a club or a red card? So, probability of club or red. Since we decided those were mutually exclusive, the probability of this situation is the probability of club plus the probability of a red card. All right, so we got to remember what's in a deck of cards. So there are 4 suits, and each suit has the same amount. So 52 divided by 4 is 13. So there are 13 clubs. There's also 13 hearts, 13 diamonds, 13 spades. There are 13 over 52 is the probability of a club. And then the probability of red, well, the card could be a heart or a diamond. Since there are 13 diamonds and 13 hearts, we have a total of 26 red cards, which is half the deck. So that is 39 over 52. And if you divide this by 13, you get 3/4. I added 1/2 plus, 1/2 plus 1/4. So I know it would work out that way, but we could just simplify this Okay, so that is our mutually exclusive example. The second example from the notes was one that was not mutually exclusive. So what is the probability of drawing a club or a king? And anytime I do this type of problem, I'm assuming it's a standard deck of 52. I will try to always put it, but so drawing a club or a king, if you draw one card from a standard deck of 52. Question mark. Oh, that looks like a big number. So a standard deck of 52. Question mark. So here we go. Probability of club. Oh, before I do that, I need to give you the formula. So I need to back up. I should have given you the formula first. So I'm going to cheat a second. So if two events, A and B, are not mutually exclusive, then the probability of A or B is the probability of A plus the probability of B minus what we call their intersection. I'm going to write it this way, and I'm going to write some notes about it. So, since these events are not mutually exclusive, I'm going to add the two probabilities, but I have to subtract off their intersection. So this is the intersection. What that means, which means any overlapping. Okay. So if I talk through my example, the probability of drawing a club or a king, so these are clubs. The overlap is the king of clubs. Okay, so that's the situation where I have a club that is also a king. Okay, so what has happened is if I add up, in fact, I'll do it. We'll start working this out. In this problem, so going back to our problem here, the probability of club or king is equal to the probability of a club plus the probability of a king minus any cards that are both clubs and king. Okay, so got to throw that away. So what I'm going to do is I'm going to show you. We're going to pick out all the clubs. Okay, you know there's 13, but all right, I'm finding all the clubs in this deck. Okay, so I've got all my clubs. And I'm also going to pick out all of my kings. and my deck of cards. And what I'm going to show you is there's a couple of ways we can handle these this or that problems in which we have some overlap like this. All right, so I'm looking for all my clubs. According to my notes, I have 4 clubs in the deck, but I'm only finding 3. Okay, so the probability of a club, if I count up all of my clubs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I missed one. 13. So I got 13 over 52 is all of my clubs. Now, watch. I'm going to find that king of clubs. All right, here's that king of clubs. The next part says to find the probability of a king, so I have to put him there. Okay, so I got 4 kings. So plus 4 over 52. But notice, I counted this king of clubs twice. I counted it over here with the clubs, and I counted it with the kings. So I have counted that twice. So since I've counted it twice, I need to subtract it off once. And that's what this minus club and king is. There's only one card that is both a club and a king. All right, so we're basically done. That's 13 plus 4 minus 1, that's 16 52s. And then that guy reduces to 4 13s. So I think that's the best way to demonstrate why this formula exists. What I could have done is if I wanted the probability of a club or king, I have grabbed all of my kings and I've grabbed all of my clubs. I could just find everything that's a club or a king. Okay, and count these out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So if I grabbed all my cards, I counted them up, I'd have 16 over 52, which reduces to that. Okay? When the numbers get really large or messy, we might choose to do this. There may be a problem in the homework where we need this formula. But in general, you might find a simpler way to do these.